This is Algebra 1, Unit 8, Lesson 1, an Introduction to Exponents. So let's just review the vocabulary for exponents. So in this case, we have 4 to the third power. The 4 is called the base, and the 3 is called the exponent. And it's read 4 to the third power, or you can say 4 cubed. Let's investigate multiplying. If you have two exponents with the same base, let's see what that would look like. So x to the second power, or we say x squared, we all know is x times x. If we multiply that times x to the fifth power, x to the fifth power is 5 x's, 1, 2, 3, 4, 5. And when we multiply those together, we end up with x to the seventh power, 7 x's. Let's try it with 5s. They have the same base, so we're allowed to do this. So we have 5 to the third power, so that means 3 5s. And we're going to multiply that times 5 to the sixth power, which means 6 5s. 1, 2, 3, 4, 5, 6. And we end up with 2, 4, 6, 8, 9, 5. So 5 to the ninth power. So you can probably see the shortcut here. When you're multiplying exponents with the same base, you're allowed to just add the exponents. That's called the product rule. So the product rule tells us that when you multiply two powers that have the same base, you can add the exponents. Let's try division. Now we're dividing exponents that have the same base. So again, on the top we have 5 x's, x, 1, 2, 3, 4, 5. And on the denominator we have x to the second power, or 2 x's. You can see we can cancel these out, and we end up with x to the third power. Let's try it with some 3's. We have 3 to the eighth power, so we know that's 1, 2, 3, 4, 5, 6, 7, 8, and that's divided by 3 to the third power, same base, 1, 2, 3. Let's cancel some of those 3's out, and we're left with 5 3's on the top. And so again, you can probably see what's happening here. When you're dividing exponents with the same base, you just subtract the exponents. 8 minus 3 gives us 5, 5 minus 2 gives us 3. That's called the quotient rule. It tells us that when we divide two powers with the same base, we can subtract the exponents. All right, one more. Now we're going to take an exponent to another power. It's called the power rule. So what this is saying is we want 3 sets of x squared, or x to the second power. So here's one set of x squared, and we want 3 of them. Here's another set of x squared, and we're supposed to have 3 of them. So we take 3 sets of x squared, and you can see we end up with 6 x's, or x to the sixth power. Let's try it with 4's. Now we want 3 sets of 4 to the third power. So that's 1, 2, and 3. Okay, so here's one set of x to the third, 2, 3, and you can see we ended up with 9 4's. So again, you probably see the secret. When you take an exponent to another exponent, or it's called the power rule, what you do is you multiply. So the power rule tells us that to raise a power to a power, just multiply the exponents. There we go. Those are our 3 rules today. Let's practice a couple problems. All right, here's the first one. We're multiplying. Remember, multiplying means we're going to add them. So I have 2 plus 6, or x to the eighth power. Again, multiplying, same base, we're just going to add those, so we get 8w to the eighth power, and the last one, 5 plus 1, we get 6. If they don't have a power there, if nothing's there, we can assume it's a 1, okay? So if you see one without a power, just go ahead and put a 1 there. Here's our division. We said when we divide, we subtract, so I take 5 minus 2, I get 3. Ooh, here's a tricky one. 3 minus a negative 5. Let's try that. 3 minus a negative 5. We know that when we do a minus minus, we change that to a plus, so that gives us g to the 8th power. Okay, we're not afraid of that. And then here we go again. This one doesn't have a power, so if there's no power there, it's assumed it's a 1. So again, we're going to subtract because we're dividing, so we have 4 minus 1, or 2 to the 3rd power. All right, let's try. Here we have the power rule, an exponent to another exponent, and we said the rule with that is we multiply. So we have a to the 3 times 4, or a to the 12th power. And this would be 3 times 5, or x to the 15th power. And this one, 2 times 10, or to the 20th power. Let me just do a couple tricky ones with you. This time the power is missing, but we have the answer. So we're dividing. When you divide, we know we subtract. So if you want to make it into an algebraic problem, you can. 5 minus what number gives us 3? And then we know we subtract 5 from each side, or negative 8 equals negative 2. Divide each side by negative 1. We get a equals 2. Maybe a lot of you are saying, hey, I did that in my head. I know 5 minus 2 gives us 3. That's perfectly fine. Go ahead and save yourself the work. Here we are, we're multiplying, so that means we add. So I have 8 plus a gives us 12. This plus this gives us this. What is that? A. Subtract 8 from each side if you'd like. We get a equals 4. We know that 8 plus 4 gives us the 12. And here we go again, a power to a power. We know that means we multiply, so I know 3 times some number is going to give me 15. Let's get rid of that multiply by 3 by dividing by 3, and we can see that our missing value is a. All right, I think you get it here. Go ahead and try the practice problems. Let me know if you have any questions. Thank you.